I am Barbara Wadsworth, and on behalf of the Graduate Student Division, we wanted to welcome everyone and thank everyone for being here today for our 6th webinar in the Pioneers in Dairy Science webinar series. Our speaker today is Dr. Kathy Soder, presenting Pasture-based Dairy Research, the Past, Present, and Future. Dr. Soder received her bachelor's degree in animal science from the Pennsylvania State University and her master's degree in animal science from Montana State University. Dr. Soder then worked as a research technician for the Montana Wool Laboratory at Montana State University before returning to graduate school to complete her PhD in animal science from the Pennsylvania State University. Her PhD research focused on nutrition and management of prepartum dairy cows. Upon graduation in 1998, she was hired by the USDA Agricultural Research Service Pasture Systems and Watershed Management Research Unit in University Park, Pennsylvania as a research animal scientist. Her current research focuses on nutrition, grazing behavior, and methane output of pasture-based dairy and livestock systems. Dr. Soder has served on the ADSA Production, Management, and Environment Committee and is currently a member of the Forages and Pastures Committee. She also serves as an ad hoc reviewer for the Journal of Dairy Science. Dr. Soder currently serves as a technical advisor to several stakeholder groups, which include the Pennsylvania Forage and Grassland Council, Pennsylvania Grazing Lands Conservation Initiative, and Pennsylvania Project Grass. So Dr. Soder, thank you very much for being with us today, and with that, I will turn it over to you.
Well, thank you. I sure appreciate the invitation and opportunity to present some of this research. It's made me do a lot of digging into some of the history and some present goings on in the pasture-based research world. And today we're going to discuss pasture-based dairy production and research in the U.S. While grazing dairy cows isn't done by the majority of dairy farmers in the U.S., there's a critical mass of small to medium-sized dairy farms that utilize grazing as a major component of their feeding management. In addition, there's larger dairies who pasture their cows during particular stages of the life cycle, such as heifers from 6 months to freshening, dry cows, and late lactation cows. At our USDA location, we conduct whole farm research with pasture-based dairy and livestock systems, mostly dairy because of the industry in Pennsylvania and the Northeast. And so as the animal scientist at the location, we conduct this research, as Barbara said, on nutrition, grazing behavior, and more recently, greenhouse gas emissions of pasture-based dairy cows. First, I'd like to provide a brief historical perspective and some grazing statistics, including how grazing is used in the dairy industry in the world compared to the U.S. Next, I'll talk briefly about grazing systems themselves, some definitions, benefits, and challenges. This will be followed by a brief discussion on pasture quality in relation to dairy nutrition, and then I'd like to touch on some economics of grazing dairy systems. And finally, I'll finish with some of the current research that we're conducting in this research area. It's been a challenge to put this much into a 45-minute presentation, and I'll do my best to keep it to that, but it is a large topic with a lot of background and a lot of history. So the first question is why pasture-based dairying? And we'll get questions like, hasn't technology made grazing obsolete? My grandfather did it, we went away from it, and why are farmers interested in grazing now? And some people view it as outdated or archaic. They recall that their grandfathers grazed cows and wonder why anybody would want to go backwards in feeding cows. However, these misconceptions aren't a true representative of today's grazing dairy. They're actually quite progressive in many ways. As we will discuss in this presentation, today's grazers have come a long way from the old stick 'em out in the back 40 and forget 'em attitude, or the use of pastures as a green exercise lot. We'll discuss how farm goals may differ from other types of dairy farms, which will impact their feeding and milk marketing strategies and decisions. We'll also look at some simple economics of grazing-based dairies and whether they are economically competitive with other types of dairy systems. So the first big question is, why would dairy farmers choose pasture-based production in the first place? There are many reasons, and I certainly won't be all-inclusive in my listing. But I think first and foremost, there are two main reasons that dairy farmers started grazing. And one is to decrease feed costs, and the other one is cow health. In relation to feed costs, letting the cow harvest her own feed has a significant impact on feed costs because there's less fossil fuel, labor, equipment, and infrastructure needed for feed storage and for feeding. But there are trade-offs too, which we'll discuss in a little bit. In relation to cow health, getting cows off concrete for part of their lactation or life cycle is beneficial to feet and leg health, and everybody recognizes that because you'll see a lot of dry lots and dirt lots in even our larger dairies. And for these reasons, even some larger dairies have their heifers custom raised on grazing farms to keep them off concrete for decreased feed costs in raising them, or to have their late lactation or dry cows out on pasture. But since then, there's been a number of other markets that have emerged, and they've promoted pasture-based diets. One of these is the artisan cheese making. There's evidence that milk from pasture-based dairy cows has different cheese-making qualities that are desirable by some cheese makers. And there's also significant evidence that grazing alters the fatty acid profile of milk, increasing some fatty acids such as conjugated linoleic acid and omega-3s, which may have human health benefits. Other specialized markets, one of the biggest ones is probably the certified organic sector, which has certainly increased the use of pasture because they are required to pasture their cows, with cows consuming a minimum of 30% pasture as a percent of total dry matter intake for a minimum of 120 days. Some organic milk processors have even placed more emphasis on pasture intake than the federal requirement, maybe requiring grazing from frost to frost, with some exemptions if there's droughts or floods, obviously, but they're even more restrictive. And finally, there's certainly a philosophical component to it for some people. They like to see cows on pasture to be in a more natural environment, and for this reason they have chosen to go this way. Prior to the 1970s, many, if not most, dairy cows were probably pastured at some point, if not all of their life. With the advent of the total mixed ration, perspectives changed. At this time, precision feeding was introduced and became much more prominent, and because there was a push for greater milk production, which required greater control over feed and nutrient intake. During the rise of the TMR and confinement feeding, fossil fuels and grain prices were also relatively low, so it was seen as advantageous to bring the cows to the barn, bring the feed to the barn, and control what they were fed. Grazing was viewed as outdated, with little to no control over what the cows consumed. And while there's not a lot of literature on how grazing was managed prior to this time, it'd probably be pretty safe to assume that concepts such as rotational grazing, improved pastures, and the like were probably not discussed. In the 1990s, there was renewed interest in grazing. There were a number of reasons, including increased input prices when fossil fuels went up and feed prices went up, but there was also an influx of experts from places like New Zealand and other countries who were brought to the U.S. by organizations and individual farmers as grazing consultants. During this time, many farmers tried to mimic that New Zealand model of grazing, which is a very low input system, a seasonal system with mostly a grass base with little to no supplementation. While there's components of the New Zealand system that are quite adaptable, our climates, forages, cows, and economics are much different. For example, the ratio of grain to milk prices in New Zealand precluded the use of grain in the ration at that time. We'll talk about that in a little bit. However, conditions in the U.S. were much different. Grain prices were low, milk prices that favored use of grain. Climatic conditions were different with different forages. The high-quality perennial ryegrass that grows so well in New Zealand doesn't fare well in much of the U.S., either to our hot, dry summers or due to cold winters. So if we can't keep those very high-energy, very lush vegetative pastures or nutritious pastures in there, we're not getting enough nutrients to the cow, so it changes the dynamics of pasture-based dairy production. The forages that were grown here are typically lower in nutrition than that perennial ryegrass. If you can grow that, that's great, but most places can't maintain a stand of that for very long. The cow genetics in New Zealand were also much different than the U.S. cow genetics. The cows in New Zealand have been selected for that type of system, whereas the U.S. cows have been selected for higher milk production. Higher milk production demands greater nutrient intake, and we couldn't get that much into them in a pasture-based system. So if we take a look at grazing statistics, they're pretty hard to come by. Up till a couple of years ago, there really wasn't even much being collected on a national basis. There are some more questions appearing in like the NASS surveys and some of those areas now, but it's still pretty hard to put some good statistics together. And even then, they're pretty incomplete. However, there's some numbers that keep consistently popping up. For example, Wisconsin has put out numerous reports that about a quarter of their farms have identified themselves as grazing farms. And this is a significant increase over a decade or two ago, which fits a timeline shown in the previous slides. Reports from Pennsylvania, where I'm located, indicate that about 10 to 15% of farms graze, and this is intensively grazing. They consider themselves grazing farms. There's probably a lot of other farms that put out certain animals but may not designate themselves as a grazing farm. In addition, we have a lot of plain sack Amish farms that are grazing in this state and in other states, including Wisconsin, that may not be included in these reports. So the numbers are probably much higher than what has been reported. New England reports similar numbers, but again, they might be underestimated due to underreporting. In most temperate regions, such as the Northeast and the upper Midwest, which I'll speak most about because that's what I'm familiar with, grazing farms have cows on pasture roughly 6 to 8 months out of the year. And during that non-grazing season, the cows are basically a confined herd because they're in the barn being fed conserved feeds. The certified organic sector does have a year-round outdoor requirement for their cows. They're allowed to be confined during inclement weather, but at other times, even in the wintertime, cows must have access to the outdoors, which can consist of either a concrete pad, dirt lot, or a pasture that will be renovated in the springtime. Other parts of the country will have different grazing seasons and time of the year and different lengths. So historically, these statistics have not sufficiently captured grazing management, which makes accurate numbers difficult to attain. And there's so much variation in what a grazing farm is that some farmers might not consider themselves grazers. So it makes this definition a very moving target depending on who you talk to. If we compare the U.S. statistics to some other parts of the world, in countries such as New Zealand and Australia, nearly all of the cows are grazed nearly all year long. There are more moderate climates allow for year-round grazing, unlike much of the U.S. Other parts of the world, such as Europe, have a grazing pattern similar to the temperate regions of the U.S., but they have more of their cows grazing than what we do, and you're looking in areas of 75 to 80% for much of the European countries that report. So what is a grazing system? There is no one definition. That's a million-dollar question. Every farm seems to be different. Management on grazing farms will range from very low input, where pastures comprise most, if not all, of the diet during the grazing season. These farms are trying to minimize feed costs and maximize use of pasture. Some of these farms tend to be seasonal, where all cows are calved in the spring within a 6 to 8 week window. This is to capitalize on the lush spring growth, and they'll have their cows at peak lactation during that growth, and then they'll tail off in later summer and fall. And in wintertime, they'll actually dry the cows off and take a 1 or 2 month vacation in the wintertime. In contrast with this, on the other extreme, is kind of a hybrid system where cows are fed most of their feed in confinement, often a TMR, and turned out on pasture for a bit of dry matter intake, but mostly for exercise. In this case, the pasture becomes the supplement to the TMR. And there's everything in between, from feeding a little bit of grain to feeding higher levels of grain, conserved forages, byproducts, anything else that's out there. You can find it on any of these farms. So there's no one model, and no two farms are alike when it comes to pasture-based systems. And the flexibility of this model is what makes it a viable option for many farms, but it's also what can cause consternation for farms with limited resources, whether they be feed, pasture, or mindset, not thinking outside the box. So there are a lot of benefits, potential benefits for grazing systems, and these include the animals. The animals are harvesting their own feed, which results in decreased feed costs in relation to harvest and storage of these feeds, but it also requires a lot of skill to maintain high-quality forages in all seasons of growth. The animals are spreading their own manure, again, decreased labor, fossil, and storage costs related to manure, but there can be issues with manure in pasture-based systems that we'll discuss here in a little bit that could be a detriment rather than a benefit. Udder cleanliness. In well-managed pasture systems, udders are typically very clean. Even in well-managed barns, there always seem to be those cows that like to lie in the gutter or any alleyway, whereas on vegetative pastures, feet, leg, and udders are typically clean. Now, this requires good laneways, vegetative pastures, no mud holes, because cows walking hock-deep in mud or standing in water do not promote udder health. In conjunction with udder cleanliness and cow stress, which I mentioned here as well, the milk quality can be high in well-managed pasture systems because they're not being exposed to as many organisms that can cause mastitis, and the immune system may be fairly strong because they're not being stressed as hard with higher levels of milk production. A lot of grazing farmers will tell you their cows are less stressed. Now, that's hard to quantify in science. I mean, we can do some hormonal measures and do some different components to evaluate stress, but they're not pushed as hard to produce as much milk as in some of the confinement systems, so their immune system is likely not as stressed, making the cows better able to fight off disease and metabolic issues. This does result in lower veterinary bills, which has been documented, lower culling rates, which has been documented, and improved overall animal health and productivity. In low-input systems, if they're outwintering cows, seasonal calving, and not keeping them in the barn, cows can be added to the system with minimal investment. You can add cows without adding a lot of infrastructure in barns and other things like that. Now, if you max out the size of your parlor, that would certainly be a consideration for capital investment. And even on cows that farms that do confine cows, often they're using lower-cost hoop houses and bedded packs. so that adding cows to the herd doesn't require quite the investment of some other systems. There can be environmental benefits to grazing, including decreased manure storage costs, decreased odor and flies due to this manure storage, but flies on cows are an issue in pasture-based systems and can be a challenge to deal with. Also, decreased soil erosion due to permanent sod of pasture systems because they're typically low to no tillage. Fewer chemicals are typically used on pasture-based systems, as well as previously mentioned lower fossil fuel usage. In addition, many pasture systems are located on marginal soils that are not as suitable for crop production. While there is cropland converted to pasture, this use of the marginal land increases the overall land available for use on a farm. And many of these grazers are raising crops in conjunction to their pastures. And many farmers report improved community relations when cows are grazing. The public likes to see animals on green grass. A final potential benefit, which will be discussed in more detail shortly, is that there's a potential for greater profitability despite lower milk production. This is primarily due to decreased input costs that outpace the lost income from lower milk production. However, this must be analyzed on a farm-by-farm basis. Now, there's a lot of benefits, but there's also challenges and potential drawbacks. And these include, when cows are grazing and selecting their own diet, this means that we as farmers or researchers have less control over what they eat. While cows are good at eating a diverse diet at pasture, we're still not able to manage dry matter intake. We can provide the feed to them, make sure they have enough available forage, but what they're eating and the diet selecting is really up to them. And pasture quality and quantity changes throughout the season. In the spring, there's a lot of lush growth. This is good in that we have a lot of yield and a lot of available pasture, but the quality may vary depending on the moisture content, which can exceed 80% in very lush spring pastures. And the rate of passage of this very wet forage, which will affect digestibility, is typically pretty high. The rate of passage, which will decrease digestibility. Unlike the bunker, where the forage will be fairly consistent until a new section is opened, pasture is changing on a daily basis as we rotate cows to new paddocks. This exacerbates the loss of control over our nutrient intake. If we're going from a pasture that perhaps has orchard grass and clover in one paddock and the next day we're going to a reed canary grass, that nutrition may vary quite widely from day to day. There's no right way to feed or manage pasture. Many people want a cookie-cutter recipe, but it takes skill as well as knowledge. And a high level of management is needed to manage pasture-based system, arguably even greater than what's required in confinement, where there's more control over the cows and the feed. In the pasture-based system, we're managing all the components of the confinement system, plus we have this fickle feed pasture, which we must work with. Other challenges include proper cow genetics. That's a must in pasture-based systems. There's as much variation within breed as a crossbreed, so it's not a simple matter of picking breed. Rather, it's more important to select genetics that are adapted to pasture. Cows are typically selected for good reproductive performance in these systems, moderate milk production, good feet and legs, and the ability to utilize high quantities of forage. Sometimes these genetics are sourced from within the U.S. from other grazers, but sometimes imported genetics are used from countries where grazing is a critical part of the industry. Cows must be behaviorally adapted. If a herd has been raised in the barn and is suddenly converted to pasture, they're likely to stand in the pasture in belly-deep grass and bellow or wait for the feed to be brought to them. They must actually learn how to graze, and sometimes this adaptation can take a generation until heifers that were raised in that system from birth enter the herd as lactating cows. While it can be an advantage that cows are spreading their own manure, they're not always spreading it evenly, which can result in pastures having uneven nutrient distribution. Water, shade, gates, water sources, and other attractants can cause cows to group up and deposit more nutrients in one spot than the others. There certainly can be a drop in milk production from confinement to grazing, even for grazing herds that first go out on pasture in the springtime. If farmers tell me that their cows increase milk production when they go out on pasture, I tell them this typically doesn't happen, and it often means there was something wrong in the barn. You don't have as much control. You really shouldn't see milk production go up significantly on pastures as you're feeding high-quality forages and a well-balanced ration in the barn. There can also be a drop in body condition if cows are not receiving adequate nutrition, especially energy, or if they have to work too hard for their pasture. If the pastures are very sparse and the cows have to do a lot of searching, or if they have to walk too far to pasture or walk up hills, walk through mud, they'll expend energy on these activities that could have been used to produce milk. Grazers must be flexible and forward-thinking. If the weather suddenly changes, or if you get a drought, or if you get a hurricane, if you get a flood, they must be prepared to change management. They have to be thinking weeks ahead of that pasture rotation. Where am I going to be a week? Where am I going to be in 2 weeks? Where am I going to be in 3 weeks? So ensure you have sufficient available pasture, or if not, what are you going to do? Are you going to bring them in the barn and feed conserved forages? Are you going to move them somewhere? Are you going to sell cows? So this is one of the biggest challenges in maintaining high-quality pastures. If we compare the quality of well-managed pastures with conserved forages, the nutrient quality of the pasture should be much higher than that of hay or silage because it's harvested at a much younger maturity level. However, maintaining that quality across the farm takes a high level of management. While one paddock is being grazed at the proper maturity level, all your other paddocks are maturing day by day. So by the time you might get out to a pasture that's 14 days from now, if you haven't staged those pastures at different maturity growth levels by grazing them or cutting them if need be, you're going to have over-mature pastures that are going to really take a hit on milk production because you won't be able to get the nutrients into the cow that should. So you really have to be forward-thinking and thinking ahead, sometimes months ahead of time, of what will I do if. So if we compare a field that's harvested as spring pasture with the same field that's harvested as hay in an early reproductive stage, and this would be a typical cool season grass pasture in the Northeast, probably some legumes in there, maybe a 10 to 30% legume. There are distinct nutritional differences. First, it's obviously dry matter. Spring pastures can be 80% or better moisture, whereas your hay is going to be 85% dry matter. Your protein is going to be higher, as will your soluble and degradable proteins, and your non-fiber carbohydrate will be higher because it's at a lower maturity rate or lower maturity, more vegetative, and will have less fiber in it, as you can see by the NDF. With the hay, we're harvesting at a more mature stage, a little bit more reproductive, and so we're going to have a different feed than what we have if we harvest the same pasture as hay or the same field as hay. The other change we have, other than that, is we have seasonal changes. If we take a look at what happens throughout the grazing season, which in our region is typically April or May through October or November. This will vary by season and by region, but you can see here that during the springtime in May and June, we have fairly high proteins, and these proteins can push 30% if it's a well-fertilized pasture or contains a lot of legume in it. Rumen degradable protein can be in the mid-70s. NDF, I've seen anywhere from 35 to 45, 50% in good pastures. Non-fiber carbohydrate in the mid-teens, and NEL, megacals per pound, is 0.7, 0.73. So if we take a look at what happens in the summertime, we're getting hotter weather, our cool season grasses are shutting down, and we're becoming more reproductive. A lot of times they're getting ahead of us in their growth, or they got ahead of us in their growth, and they're doing a lot more lignification of the fiber. So there's a lot more fiber, as you can see in the NDF, and sometimes it'll get into the high 50s or even 60s in some poorer quality pastures. Protein has dropped, rumen degradable protein has dropped, energy has dropped as well. In the fall, we'll have a little bit of a rebound as we get cooler temperatures and more moisture again throughout these temperate regions, and we'll have a rebound that'll be similar to the spring growth. So what's the consequences of limitations and imbalances in these pastures? We talked about having a lot of protein, particularly rumen degradable protein in the rumen. You have this fast degradation, fast nutrient passage rate, you get some loose manure, rate of passage, decreased digestibility. You can have reduced milk fat, a lot of that due to the reduced fiber or insufficient fiber. You don't have the cud chewing, you don't have that effect to keep the rumen buffered to maintain milk fat percentages. Obviously, this can all result in reduced milk production. And we have an inefficient use of highly degradable protein in pasture. If we don't have the energy available to recapture that ammonia when the degradable protein breaks down, it's going to be excreted as urea. And this is a cost to the animal, and this can equal, I've seen reports that equal of 2 to 4 pounds of milk per cow. So not only are we losing milk, we're affecting our cow productivity, there's also environmental considerations with these high levels of nitrogen as urea in the urine, which is quite volatile. So if we're taking a look at our pasture with various levels of milk production, the first limiting nutrient at any level of milk production is energy. Data by Eric Culver and Larry Muller at Penn State showed that high-quality pastures are able to support between 45 and 55 pounds of milk per day. This was with Holstein cows. Protein supplementation wasn't necessary at these milk levels as there is an excess of protein, especially the rumen degradable protein in well-managed pastures. Since energy is first limiting, and if we look above this target level, we get into 65, 75 or more pounds of milk, energy supplementation would certainly be warranted to maintain those production levels and maintain reproductive efficiency in these cows. They also showed that in herds producing 75 pounds of milk per day or greater, there may be a need for protein, but it's a bypass protein source to meet the nutrient needs of those cows. So with grazing systems, we have the science, and we have a little bit of the science we're going to talk about in a minute, but we really need to have an art. You have to listen to what the cow is telling you, watch what the pastures are telling you, and be able to react quickly and be proactive on what you see coming, so you don't go out and have a train wreck and have cows that drop in milk production and don't regain that. And much of the science has been conducted in other regions of the world, not the U.S. We need local information to better understand nutrient requirements, forage growth, and pasture management for these specific regions. And even though the research has been conducted in the U.S., it won't apply universally across the country with our varied climates. Much of the science used by farmers, consultants, and other farm professionals comes from other countries that have different genetics, forages, economics, and climates. One of the biggest mindset changes between grazing-based systems and a lot of confinement systems, a paradigm shift, is when converting to a grazing system is that the emphasis is not on making maximum milk production. They're using a lot of precision feeding to increase milk production by a few pounds here, a few pounds there, but rather the emphasis is on economic optimization. And often this means that greater emphasis is put on cutting costs, especially feed costs, recognizing that milk production may and will decrease, but the reduction in cost must outpace the reduction in milk production while maintaining cow health and productivity. And you may hear grazers and economists use terms like hundredweight of milk per acre rather than hundredweight per cow. And so we have some farms that are profitable at 8, 9, 10,000 pounds of milk. Some of them are marketing their own milk, some of them are marketing through the common sources. Economic data on grazing farms is really limited and sometimes a bit dated. However, there's still some numbers that apply, particularly in relative terms when comparing systems. Wisconsin has done a nice job. Tom Kriegel out there has done a nice job of putting out some data showing the rolling herd average for various size grazing operations. If you look, most of these herds are 100 cows or less. They're small herds, they're not large. There's a few that are greater than 200 cows. But in all categories, no matter what size, the bulk of the herds were between 16 and 20,000 pounds of milk. This is 2004 data. I would suspect that this average may be dropped a little bit as more farms have gone to lower grain inputs, and maybe the milk yield milk production has gone down on those cows. So, and a number of these herds are marketing their own milk, whether it be bottled milk, raw or pasteurized, or processed products such as cheese, ice cream, or yogurt. But the take home here is that the milk production is moderate, and that is one of the goals of these farms. If we take a look at herd sizes on management-intensive grazing and non-management-intensive grazing, basically rotational grazing versus those that may not be managing as heavily, the management-intensive grazing are in green, well, they call this is again Wisconsin data, confinement dairies. Looking at the herd size, the herd sizes are fairly small in grazing herds, pretty similar across other states like Pennsylvania too. One of those reasons for the herd sizes are that a high number of Amish and other plain-stuck herds graze and have small herds. In instances such as Lancaster County, Pennsylvania, these herds are landlocked and can't expand even if they wanted to, so they're seeking to decrease input costs through grazing. In addition, some of these herds would be organic, certified organic, so they'd be seeking a higher milk price, but recognizing the cost of producing certified organic milk is also higher. Another factor that may limit herd size is adequate pasture within walking distance of the milking parlor. The further a cow has to walk, the more energy is expended in this activity that could have been used for milk production. Typically, herds like to keep the walking distance to a half a mile or less one way for a total of 2 miles walked per day if milked twice a day. There are some herds that walk cows a mile or slightly more one way. However, there are concessions that have to be made. Some of these herds only milk once a day, so they're only walking cows once a day rather than twice a day. Others are only walking cows that far once a day and maybe putting them in a pasture close to the barn, perhaps at night where they don't have to walk so far to get them early in the morning. Another way to look at grazing farms is milk-to-feed price ratios, how that compares in the U.S. versus other countries. It's always been very positive for the U.S., meaning it's historically been economically beneficial to feed at least some grain to dairy cows. The U.S. ratio has often been above 2, which favors supplemental feeding. So if we compare this ratio to other countries, such as New Zealand and Germany, you can see that the cost of feed, particularly grain, has been much more expensive relative to the price of milk. In these systems, it's not often beneficial to feed high levels of grain, sometimes no grain at all. So when the New Zealand consultants came in the 90s and were trying, and the American farmers were trying to just directly apply this, the economics just weren't playing out, and it just didn't make sense to completely adapt a model. They had to take it and modify it to make it work here. There's also a lot of variation between years. In 2012 and 2013, in the red and the blue, when feed prices were high, the ratio dropped well below 2, which caused many farmers, especially grazers, to reconsider their supplemental feeding programs. 2014 is shown to be much more beneficial with feed prices lower and milk prices higher, so more grain may be fed during these times. This data from Tom Kriegel in Wisconsin compares grazing, certified organic, all confinement, and then he split out smaller confined herds and larger confinement herds in terms of net farm income from operations. The grazing herds, whether you're looking at breaking out organic or all grazing herds, had the highest net farm income from operations, with the grazing herds the highest, the organic herds the second, while the confinement herds typically had lower. Well, in general, this is due to lower input costs, therefore net farm income was greater and there was greater profitability. Doesn't mean all grazing farms are profitable. You still have to be well managed, you still have to control your costs. So what supplementation options are there for grazing farms? Well, basically anything that you can feed any cow can be used in grazing systems. And there's everything from just grain to silage to haylage to haze to byproducts to a TMR. Everything's out there. But the main difference is that a portion of the diet, the pasture, is not fed in the barn. But we can still use it to formulate rations. If we know the forage quality and the approximate pasture dry matter intake is known, then we can include it in the ration formulation. But how do we know dry matter intake? It's been estimated because we can't measure it, even in research trials. Some farmers will just simply substitute pasture for haylage or grass on a one-to-one basis. So pull out 10 pounds of dry matter of haylage and assume the cows are consuming 1 pound or 10 pounds of dry matter pasture. Now, we have to have sufficient pasture quality and quantity out there for this to occur. In research, we will do this by a number of methods through external markers or taking samples pre- and post-grazing and measuring disappearance. But in any event, any type of supplementation can be used. Again, some data from Larry Muller at Penn State showed that there's a nice curvilinear response in grain supplementation and milk response. It's also a law of diminishing returns. At lower levels of grain supplementation, you get more milk per pound of grain. You're getting between 1.3 and 1.1 pounds of milk per every pound of grain, up to about 10 pounds of grain. Above that, you're getting roughly 1 pound of milk for 1 pound of grain, and then this drops off that you're getting less than 1 pound of milk per pound of grain. So what farmers need to do, and researchers, when we're looking at economics, is find where is that optimum level, not necessarily maximum, but what optimum level relative to milk and grain prices. One feeding strategy that's becoming more popular in the grazing sector, especially in some of the organic sectors, is low to no grain diets, all forage, all pasture diets. It can and is being successfully done with cows that produce moderate amounts of milk, have few health issues, and breed efficiently. But this type of feeding system takes a very high level of management and it's not recommended for new grazers who are learning all about aspects of grazing systems. A diet that's primarily pasture-based requires very high quality. I keep saying that, but it's really the pivotal point of the whole system. This requires a combination of planting improved forage species that have greater nutrient content than traditional or wild species that grow in our pastures, and then we have to manage those to maintain that quality through mechanical harvest, grazing, soil fertility, and controlling undesirable plant species. Proper adapted genetics will be crucial to the success in reducing or eliminating grain in the diet. Asking a cow with a genetic potential to produce copious quantities of milk to survive on pasture is only asking for disaster. Produce the animal that fits the system. There's some specialty markets emerging, such as grass-fed milk, that are paying a premium for such management. So even though milk production may be lower, there may be incentive payments available to help offset that cost. Right now, this is pretty regional. A couple of them are trying to get a national effort out there. There is a public demand for it, so that's one option for some grazers. One of the biggest incentives to reducing or eliminating grain in the diet was the increased price of corn, especially certified organic corn, which was in the high teens per bushel at times, and limited grain availability, especially for the organic grazers. This has forced them to look at alternatives to corn or to reduce the grain in the ration. However, there's not much scientific data on alternatives or feeding these low to no grain diets with cow genetics, climate, and forages in the U.S. So I wanted to talk a little bit about some of the research that we've been conducting with grazing dairy cows. There's a variety of reasons for this, including relatively low percentage of total cows that graze because there's been very little research. There's a lack of funding because the grazing industry isn't nearly as tied to commodity markets, which can provide funding for other types of dairy research. The need for pasture land is great when you're doing research studies, so there isn't that available or there isn't funding for that available in many university dairies. And there's difficulty in conducting this type of research due to so many uncontrollable variables, the weather, forage quality, not being able to actually measure intake. So there's a lot of issues that can be confusing for folks who are trying to conduct this research. I've been fortunate to work with some university collaborators that have grazing herds and also with a lot of cooperating farmers to conduct on-farm trials to answer questions that they ask of us, but to which there aren't answers that are relevant to our situation since most of the grazing research comes from other parts of the world. So I just want to spend a few minutes talking about some of that research we conducted, particularly in relation to alternative supplementation strategies. The first question, or one of the first questions we were really getting, was looking at alternative supplementation in molasses. The grazing dairy industry, particularly the organic sector, became interested in molasses when corn prices went high and corn availability was low with ethanol plants and limited organic corn, limited conventional corn. Molasses is a high-energy feed containing 14 different sugars. It can be less expensive than corn, depending on price. We were receiving inquiries on using it in lieu of corn, but had no scientific data. Of the research that was available, it was either in combination with other supplements, but not molasses alone. It was with other animal types, particularly beef cows, or within very different feeds, pasture quality or conserved forages, not in the conditions that we were finding in the Northeast. Additionally, there were some pretty persuasive farmer testimonials claiming that molasses could be fed at 1/3 the rate of corn. They were saying it had 3 times the energy of corn, which did not make sense to us because the NRC states that it has a similar energy content to many of our grains. So while it's an energy source like corn, it contains sucrose rather than starch, which is metabolized in the rumen differently and can cause rumen issues at high feeding levels. Therefore, we conducted a series of studies to evaluate molasses as a primary energy source in pasture-based diets. We started with continuous culture fermenter studies to evaluate the effects of molasses on rumen fermentation. Molasses was fed at 5% of total dry matter fed to the fermenters, and this was to mimic what was happening on farms. And cornmeal was fed at 7% of total dry matter fed, again mimicking farms and also to be as isoenergetic as we could get it to a pasture-based diet. We also fed a combination of these 2 supplements at those same levels, so we were feeding 12% total supplement in that diet to mimic what was happening on farms. When we looked at this, we found no changes in volatile fatty acid production and no changes in bacterial protein production, nor did we see differences in dry matter or NDF digestibilities at these feeding levels. So these are fairly low feeding levels, but this is what farmers were doing, so we wanted to mimic what they were doing and see what type of effects we could see. Fermenter ammonia concentrations decreased with the combined diet, but this isn't surprising because we simply decreased nitrogen intake. We're substituting the lower protein supplement for some of the pasture, and this may vary with greater supplementation levels. All fermenters showed sufficient ammonia growth or levels to stimulate microbial growth. So our conclusion from this study was that molasses responded similarly to cornmeal in fermentation parameters, and neither supplement vastly changed fermentation at these low levels of inclusion. So then we moved on to a cow study. We did a couple other studies looking at forage quality interactions and really saw nothing there. So we moved on to a cow study. It was kind of going at the same time or right after these fermenter studies. It was the University of New Hampshire's organic dairy herd. Lactating Jersey cows graze pasture and consume baleage at 18% of dry matter intake for the baleage, and either molasses or cornmeal at 12% of their total dry matter intake. The cows were supplemented with molasses, had a greater milk production than cows supplemented with cornmeal. Milk components were similar between treatments, with milk fat averaging 4.8% and milk protein averaging 3.5% in these Jersey cows. Pasture intake, which was estimated using clip plots before and after grazing, was similar between the 2 treatments. The supplement intake was greater for the molasses cows and seemed to be related to increased baleage intake in this group, because when we were top dressing the molasses on the baleage, it might have helped stimulate intake of them because sometimes there was refusals of baleage or they didn't clean it up because they wanted to get back out on pasture. But total dry matter intake was similar between the treatments. Analysis is going on for this study, including individual fatty acid profiles, grazing behavior, pasture data, and final statistics. And so we will be completing this within the next 6 to 12 months. The third component of this molasses research was looking at molasses as a primary energy source on an organic grazing dairy farm. We conducted this in collaboration with USDA Natural Resources Conservation Service in New York and with Cornell University. We looked at a farm in New York who was feeding molasses as their primary supplement for 2 years. During the first year, the farmer fed 3 pounds of molasses and 1 pound of cornmeal barley grain mix. During the second year, he increased the corn mix. This is a case study, so we were observing what he was doing. So during the second year, he increased the corn mix a bit to 2 to 3 pounds of corn with 2 to 3 pounds of molasses. He varied a little bit by season due to the low body condition during the first year. He wasn't happy with the body condition and milk production that first year. So we collected cow milk, pasture samples monthly on the farm. In addition, the Cornell net carbohydrate and protein system was used to analyze the diets. So over the 2 years, the cows produced more milk than what was predicted by the model. And this may have been due to cows utilizing back fat early in lactation as body condition dropped to an average of around 2 at peak milk. The cows were a little bit on the thin side at times, and so they might have been using back fat, which we couldn't evaluate it in this study, but may have affected reproductive efficiency of those animals. The milk production levels in this study did not support the 3-to-1 energy testimonial, rather the 1-to-1 conversion is listed in the NRC. This was a seasonal herd with all cows calving in around March and April. And the cows reached peak milk in late May at around 50 pounds per cow and dropped through the summer to an average of 30 pounds per cow. As you can see, there wasn't a lot of difference in milk production between the 2 years, but he did see a little bit of a benefit in body condition in the cows by including a little bit more starch in the diet. The sugar from molasses may not compensate for lack of starch in the diet, suggesting that perhaps some starch is required to improve ruminal fermentation. The higher starch appeared to improve body condition, milk production, and milk urea nitrogens. The MUNs are shown here. Despite the slight differences noted, the MUNs were actually much higher than what's recommended. It is important to note that during the second year in 2009, the cows reached a positive energy balance sooner, most likely due to higher pasture quality that year, and it's reflective of the MUNs whenever they started dropping a little bit sooner than what they did in 2008. So combined with the other results of this study, this suggests that greater supplemental energy may be warranted to improve milk production, body condition, and ruminal fermentation. Molasses can be used as an energy supplement for grazing dairy cows. However, at these low levels typically fed, they may not make great improvements, and it responds similarly to corn at similar levels. A combination of these two energy sources, possibly at higher levels if economics warrants it, may provide a balance of energy sources while helping to decrease costs when one becomes more expensive than the other. So that kind of sums up our molasses work, and now I'd like to move on briefly to another alternative energy supplement that we're currently looking at. We've gotten a lot of questions on flaxseed as an alternative energy source and for some of the additional benefits that it may provide in milk quality. Flaxseed is an oil seed that's rich in omega-3 fatty acids and alpha-linolenic acid, which has been found to increase beneficial fatty acids in milk. Flaxseed's also been investigated as an alternative energy source in grazing herds. It's been shown to decrease methane in cows fed conserved feeds, but it's not been evaluated in pasture-based diets. It's commonly known that low-grain diets, high forage diets, favor methanogenesis, so one way to reduce this impact is to find supplemental sources to mediate the effect, not only for environmental impacts, but for animal efficiency. Therefore, our hypothesis was that replacing pasture with incremental levels of flaxseed will reduce methane without impairing ruminal fermentation. So we went to the fermenters again and said 0, 5, 10, or 15% flaxseed to an orthograph diet and looked at methane production. And you can see 0 and 5% it was starting to decrease, but certainly at 10 and 50% we had a significant decrease in methane production, which was very promising until we looked at nutrient digestibility, which is not surprising since they're so linked. We saw decreased organic matter and MDF digestibility as flaxseed supplementation increased. So this could potentially impact dry matter intake at the cow level, which would in turn impact milk production. The results of this study indicate that further research was needed at the cow level. Therefore, we developed a cow level study where we're currently evaluating the effects of flaxseed on milk quality, methane emissions, animal health, and reproduction on a large scale on-farm case study. It's a collaborative effort by the University of New Hampshire, our lab, the Cornell universities, the University of Maine, and the University of Vermont. We have 14 commercial dairy farms in 5 states on this 4-year study. We're monitoring feed and pasture nutrient quality, body weights, body condition, milk production, milk components, and milk fatty acid profiles year-round. We're conducting a 2-year winter feeding study on 11 of the farms. The herds are split in 2, and half of the lactating cows are fed flaxseed, substituting flaxseed for some of their grain supplement, and the other ones are fed whatever grain supplement has been typically fed on the farm, keeping the diets as isoenergetic as possible. We collect monthly milk samples to be analyzed for fatty acid profile, which is ongoing. We've completed 1 year of the winter feeding study, and we'll repeat it this upcoming year. What we're trying to do is when you look at fatty acid profiles of grazing cows, you tend to have increases in the CLAs and the omega-3s and some of the beneficial fatty acids during the grazing season, but during the wintertime, those fatty acids decrease because they're back in a confinement system. So we're looking for a way to maintain the higher fatty acid profile, the more positive profile for milk marketing and for purposes such as what I mentioned with a lot of these specialty milks. So there was also a study conducted at University of New Hampshire in the lower left-hand corner there that mimicked the fermenter study, feeding 0 through 15% flaxseed to these grazing cows, and as you can see, what we expected to happen did. As flaxseed increased at that 10 and 15% level, milk production did decrease in those animals, in these Jersey cows. Now what we did this year is we fed about 6% flaxseed in these cows on these on-farm studies to kind of avoid those detrimental effects while maintaining the beneficial effects that we hope to see. Again, ongoing study, no results yet. I just wanted to finish up with another component. I'm not a geneticist, but this is a question that we get all the time, is related to grazing genetics. It's an area that certainly needs to be researched for grazing herds. There's a lot of discussion amongst farmers and research about which cow breed, cow type, crossbreed makes the best grazing animal. So we have a lot of farms. You go to grazing farms, they're very colorful herds, a lot of crossbreds, a lot of novelty breeds, a lot of minor breeds. And so there are a lot of questions that need to be answered regarding cow genetics, because sometimes it seems to be random breeding that occurs, and once you get beyond an F1 or an F2 cross, the results tend to be quite variable on how productive those animals are. So in summary, pasture is a nutritious, low-cost feed for dairy cows in all stages of life. Grazing is obviously not for everyone, but particularly for small to moderate farms on marginal soils, limited land bases, and the potential for alternative milk markets, grazing may be an alternative to consider. Grazing cows can be quite profitable, but it requires a high level of management. Low to no grain diets are feasible, but again, require high management and marketing skills, because if you want to produce that milk, you need to have a market for it. And pasture-based dairying is not the backwoods, no technology, lack of management that may have been used by previous generations. Many grazers take advantage of new technologies and management strategies. Many grazers will assert they travel the world looking for new technologies for grazing systems to bring back to the U.S. They assert that grazing is what allowed them to stay in business, especially as a small family farm. There also seems to be a high rate of the younger generation staying on the farm to continue the family operation. More research is needed to provide scientific information to the small yet crucial component of the dairy industry. With that, I will finish. I see there's some questions popping up, and I will take questions at this time.
Great, thank you, Dr. Soder. We actually have 2 questions available right now, so we'll just jump into them. Eric is interested in hearing your opinion about the conundrums of needing to increase food production for population in a lower production method of farming.
That's always a hot topic amongst the different sectors of the dairy industry, and my take on it is there's room for everybody. We need the large-scale production to basically feed the world. But we also have another sector that is keeping family farms in business, using land that may not have been otherwise used, whether it be for corn production or other livestock production. If we can graze animals on it, whether it's beef cows, dairy cows, small ruminants, whatever it might be, we can improve and utilize those lands. I think some people feel threatened by that, but when you look at, for example, the organic milk market, it's 6% of the total fluid milk market. It's not a large percentage, but if you look at the number of farmers that it has kept in business, I think that's an important component to look at.
Great, thank you. And Eric actually has another question, and how do you feel about the pressure to reduce greenhouse gas emissions when pasture cows produce more methane per unit of milk than confinement cows? And does the lack of manure slurry tank emissions offset this increase per unit?
The latter part of that I can't answer. I'd have to go next door to one of the soil scientists who's working on that. But if Eric's interested, he can email me about that. But looking at, there's actually a lot of controversy on who's producing more methane. You know, it depends on how you look at it. When you're looking at it per unit of milk produced, sure, but you have to look at the bigger picture as well. And I'm not going to advocate either system because nobody has been able to look at the whole picture. Let's also look at the carbon sequestration and the retention of nutrients in the soil. And actually the methane changes in the forages in the soils, which we have somebody looking at here. So what's the total balance on the farm? Maybe not just what's coming out of the cow, but on the whole farm. And I think, you know, there are so many studies out there that are truly on either side of this issue biased to answer the question that they would like to ask without looking at the whole picture. I think nobody's looked at the whole picture because it's too difficult to look at, but we keep coming up with this question, but how do we answer it?
Great, thank you. I actually have a question about how can producers kind of implement the current grazing research that's going on right now? Sometimes it's hard to kind of keep current, especially if they have to wait for, you know, forages to grow and stuff. So how can they keep current and kind of implement the current research that's going on?
I mean, are you talking about somebody that's just starting to graze, or?
Or somebody that's been grazing for a while, either.
Okay, well, there's a lot of different ways the current research is getting out there. There are, for example, Pennsylvania has some incredible grazing resources here in our NRCS people. We have 5 grazing specialists who come to your farm and will make recommendations, help you lay out the farm, grazing plans, and all of that. And there's some other states, New York and others, that have some great people as well. And they can help out. They are pretty current on the research. They put on a lot of field days so you can get out and see other farms. There's a lot of websites and the On Pasture online news article. Shout out to those folks if any of them are on here are putting out current research all the time. Some of these farmers are going to other countries or they're bringing people in. They're still doing that. A lot of them do a lot of international travel and they're bringing things back to us, asking questions, and then we're looking at something. But networking with other folks as well, other farmers, and what they're doing within their region and across the country. And that's where I think that the internet and social media can really come into play.
Great, thank you. We have another question. It says, you mentioned that grazing is an art and requires knowledge and skill. Where would you direct farmers, nutritionists, and consultants who would like to learn more about grazing and how to implement it on the farm, which goes kind of what you just said, actually?
How you would learn that art is basically actually by getting on the farm and doing it. For those who would like to graze, there's a lot of young farmers who are becoming an intern or a mentee under somebody else. There's actually a pretty strong mentor program going on in this state for young grazers, and they can hook up with a experienced grazer or a group of experienced grazers to ask questions, have them come to their farm, go to their farm, spend a month on their farm, spend 6 months on their farm to learn that. There are some farms offering internships to help people learn that. There's a lot of international internships. But it's really doing. You can't do that on the internet. You can't do that through a textbook or through a college course. You have to be out there doing it.
Great, thank you. Tina just made a comment that says that there's also grazing conferences around the country, and that the Mid-Atlantic Dairy Grazing Conference is coming up in November, November 12th to 3rd in Georgia.
Yeah, there's a number of them throughout the country, so you know, certainly watch for them.
I have another question that just came in. Tina was wondering, do you think that grinding flaxseed or roasting it first would change the results of the effects on milk production?
Would grinding it or roasting it? It was a whole flaxseed that we fed, but we did grind it because the whole flaxseed would go through the animal. But by whole flaxseed, I meant that the oils were not extracted from it. I think it was I can't remember if it was a roasted product or not, I'm sorry, but yeah, now the problem with grinding it is that it will oxidize, so the shelf life isn't too long on it. The product that we used has a proprietary process to it that really helped stabilize it, and we did not have issues with oxidation. So yes, grinding it will help, but you'd have to kind of grind it as you go type of thing, not buy a large bin of pre-ground flaxseed.
Awesome, thank you. I don't see any more questions coming. Oh, I might have one. Okay, yep, we have another question by Tina. It says, what price do you think organic milk would have to reach to convince more current dairy grazers to go organic?
Well, with this year, with the price of conventional milk being higher, it's less convincing to go that route. It's not really, I think, a matter of what price the organic milk has to be at, but I think it's relative to conventional milk, and perhaps how closely the production management is on that farm to organic. There's a lot of farms that stay away from a lot of things that are prohibited in organic, some of the herbicides, pesticides, GMOs, whatever it is, that don't certify, but they're very close to it. And if there is no magic answer. I know Bob Parsons has also done a lot of work at University of Vermont on this. He'd be a good one to ask, but I wouldn't say there's a magic number. I think it's all relative to what the confinement milk is, and also the input prices as well. And if you have a market for your milk, if you're out somewhere where the processor can't reach you or it's not worth their while to reach you, you may not be able to get anybody to pick up your milk.
Great, awesome. Thank you so much. Well, I can't see that any more questions are coming in. So everyone, we just wanted to thank you for being with us today, and thank you very much, Dr. Soder, for a great presentation. Please watch your inbox in the ADSA-GSE webpage for more info about our next webinar, which will be held August 20th at 12 p.m. Central Time, where Dr. Hutchins will be speaking. So again, on behalf of the Graduate Student Division, thank you so much for everyone for joining us today.
Thank you.